In this video, we'll look at calculator preparation from the point of view of using the solve command versus using the zeros command. The first example is to find the sum of the solutions to the equation sec 3x equals 2 and x belongs between 0 and 2 pi. To access the solve command, you should be quite familiar with this. We'll press menu and then number 3 for algebra and then 1 or enter for solve. To access sec, you could use your keypad and type in SEC, or you can press trig and then scroll across to sec and press enter. When you do that, it comes with your opening and closing brackets. Inside there, we will put 3 times x, and then we'll move across 1. It equals 2, so we press equals 2. And whenever we solve an equation, it's equation comma the variable that we want to solve for. So in this instance, x. Then we move outside the closing bracket there. And to add our domain constraint, what we do is we press control equals. And then if you arrow once to the right, twice to the right, and then down 1, we get the given symbol, the with or the given key. It's the same symbol that's used in conditional probability. So we press enter, and then that pastes the with or given command icon onto the home screen. And then it's a matter of saying that we want to solve this equation between 0 and 2 pi. So we press 0. To get less than or equal to, control equals, and then we access the less than or equal to sign, and then we press X, and then control equals, and then we access the less than or equal to sign, and then we press 2, and then if we press the pi key, notice that we can automatically press enter. That pastes pi onto the entry line there, and if we press enter, what we get is we get 6 solutions, which you can see 4 of them there. And then if you go up 1, you can see that the last 2 there are 13 pi on 9, 17 pi on 9. So if you wanted to sum them up, what you would have to do is you would have to edit that, that output, and it's quite fiddly to do so and time consuming. So a more time efficient approach in finding the sum of these solutions is to use the zeros command. And to do this, what we will do now is we'll, on a new entry line, we'll press menu, then 3 for algebra, and number 4 for zeros. Now, what we type in here is assumed to be set equal to 0. So our equation was sec 3x equals 2. So what we type in actually in this instance is, we go to trig, sec, and then 3 multiplied by x. What we're going to do now is we're just going to subtract 2 from both sides, so it becomes minus 2. So that is what's assumed to be set equal to 0. Then we press the comma x. So in other words, it's the equation there, expression, if you like, assumed to be set to 0, comma the independent variable. And then we come outside the bracket and we'll repeat the addition of the domain constraint. So control equals. If you go 1 to the left, you actually access the with or the given command automatically, which is quite good. And then what we will do is we'll go 0, and we'll go less than or equal to x, and then less than or equal to 2 pi. You can also type in pi, pi as well if you like. And when we press enter, what happens is we get our solutions specified in the form of a list, which is quite nice. And what we can do with a list is we can sum the elements within a list. Now, the command we're going to use is the sum command, which you could use your keypad to type in SUM. Where to find the sum command is if you press menu. It's not intuitive where it is. Number 6 for statistics, and then press number 3 for list math, and then number 5, sum of elements. And there we get the sum command. And what we can do is if we now arrow up to highlight our last output and then press enter, and what that does is it pastes that list into the new entry line. And so this entry line is saying, well, we want to sum all the elements that are in this list. And if we press enter, we therefore get 6pi. So that illustrates that the zeros command has some time efficient advantages over the solve command. And my feeling is that it's an excellent idea to be au fait with the zeros command and when it's a good time to use it in the exam. Moving on, we have a second short example that also illustrates the advantage of using the zeros command. And this simple example is asking us to find the coordinates of the point of inflection on the graph of y equals e to the power of x times sine x over the domain 0 to 2 pi. You don't need to do this, but we'll show you how to assign e to the power of x times sine x as a function. Is we'll say, let's have f of x, and we're going to assign that. So the assign command is press Control and then the symbols template. So that that's the assign command, colon equals. So we're going to assign f of x to be e to the power of x. Now don't press letter E, press the e to the x button. So that's e to the x, and then we're going to multiply that by sine x. So press trig, sine x, and then press enter. And we've now assigned f of x to be e of x times sine x. You can also use the define command, and if you're used to using the define command, certainly stick with that. That's no problems at all. Now, we're after the coordinates of a point of inflection. So what we need to do is we need to find the second derivative of f with respect to x. We could differentiate one at a time to find the first derivative and then the second derivative. If we go to the catalogue, what you'll note in the second row is there is a template for us to find the second derivative, which is currently highlighted there. So with it highlighted, you press enter, and our template, all we need to do now is to enter what our independent variable is. So in that box there, we put in x, then move across to this box here, and we've defined our function or assigned our function to be f of x. So if we type in f open bracket x here and then press enter, that gives us our second derivative. And in attempting to locate the coordinates of the point of inflection, what we need to do is we need to take the second derivative and set it to 0 and solve for x. And there might be more than one point of inflection over this domain from 0 to 2 pi. So in this instance, it would be really useful to use the zeros command again, rather than the solve command, because it's more time efficient and it's a more direct way of finding coordinates of special points. So if we press menu, then number 3 for algebra, number 4 for zeros, what we can do here is we can be a bit clever. We could take 2 times e to the x times cos x and put that in our zeros command. We could also take the second derivative there, so it doesn't matter which one we paste in. So with that highlighted, we press enter. We then are assuming that this is set equal to 0, and hence the zeros command. Then what we do is we say, well, okay, we want to find the zeros with respect to x, so it's comma x. And then, as I showed in the previous example, it's a matter now of adding our domain constraint. So I'll just type that in So control equals, go 1 to the left for the width or the given symbol. And then again, it's 0, and then control equals, finding the less than or equal to sign, x, and then control equals, find the less than or equal to sign again, and then 2. And just to show you that, you know, you can type in PI, see how it went from italicized to non-italicized. So you can type in PI and the calculator will recognize that as pi. And then when we press enter, they're the 2 x coordinates of the points of inflection, and they're represented as a list, pi on 2 and 3 pi on 2. And the great thing about having the coordinates in the form of a list is we can now perform a direct substitution. We don't need to edit a line that might say x equals pi on 2 or x equals 3 pi on 2. So if we now press F and then open bracket, go up and grab our list, bring it down to a new entry line, and then press enter, we can see that the 2 points of inflection have coordinates pi on 2, e to the pi on 2, and 3 pi on 2, negative e to the 3 pi on 2.